Good day students, this is mathematics class for grade 8, chapter 1, rational numbers. In today's video session, let us learn the representation of rational numbers on the number line. We know that natural numbers, whole numbers and integers can be represented on the number line. Like these numbers, even rational numbers can also be shown on a number line. To express rational numbers on a number line, we need to divide each unit length into as many number of equal parts as the denominator of the rational number, and then mark the rational numbers on the number line. A number line looks like this. The positive integers are represented to the right of 0 and the negative integers are represented towards the left of 0. The numbers increase when we move towards the right and the numbers decrease when we move towards the left. It is easy to represent integers on a number line. But how do we represent numbers like 1 by 2, 3 by 4, etc.? Before we understand how to represent these numbers, we need to understand an important point. Every integer except 0 has the corresponding integer. The integer 1 has -1 as its corresponding integer. The integer 2 has -2 as its corresponding integer. Similarly, every negative integer will have the corresponding positive integer. Here we have 1 by 2. So its corresponding integer will be -1 by 2. And we have the number 3 by 4. So its corresponding integer will be -3 by 4. Next, let us move on to the representation of rational numbers on a number line. We have two types of representation of rational numbers on a number line. They are, one is numerator is less than the denominator and the other is numerator is greater than the denominator. One is numerator is less than the denominator, and here the next one is numerator is greater than the denominator. Numerator is less than the denominator. For example, numbers like 1 by 2, 3 by 4, 1 by 4. So here we have the numerator which is less than the denominator. 3 is less than 4. 1 is less than 4. 1 is less than 2. Is this clear to you? Yes. Next one. The numerator is greater than the denominator. For example, 7 by 2, 10 by 7, 4 by 2. So here we find the numerator is greater than the denominator. So 7 is the numerator, 2 is the denominator. So 7 is greater than the denominator, 10 is greater than 7, 4 is greater than 2. So here we find the numerator is greater than the denominator. And in this type we find the numerator is less than the denominator. So is this clear, students? Okay. Now for example, if we are representing minus 7 by 2. So here 7, we have a positive rational number, that is plus 7 by 2. Okay, so this number comes in the category of numerator is greater than the denominator. But what about minus 7 by 2? So here, while we are representing minus 7 by 2, we compare only the numbers 7 and 2 and not minus 7 and 2. So here minus 7 by 2 will come in the numerator is greater than the denominator category. So minus 7 by 2 falls in the category numerator is greater than the denominator.